We are going to talk more about resonance in this video. So before we're explaining the little cation, and we talk about the convention that we use for resonance. So we're going to be using an arrow to represent movement of electrons, and we're going to use the arrow that is double-headed to represent, say, more that there's more than one structure. Now, if you look at the movement of the electrons, now the pi electrons have moved over, say this is 1, 2, 3, now they have moved over between carbon 2 and 3, and we're going to make a double bond there, and now you have your positive charge. Those are my two resonance structures, and we represent the hybrid as partial double bond here, partial positive charge, partial positive here, and that's my hybrid. Now we can do another system. Say, for example, that I had something like that, and I am going to add an NH2. So this is an amide, so acetamide, by the way. And here, what we're going to say is that in the nitrogen atom, we're also say that this is sp2 hybridized, and same for the carbon and for the oxygen. Now, what we're going to do now is move again. Arrows need to show the movement of electrons. And that is important, always. That's our convention. So now I'm going to move electrons from the lone pair at the nitrogen, and I'm going to move it over here. And here, something that is important is that the carbon that it is here already has 4 bonds. So 1, 2, 3 bonds, meaning octet is complete. So not to violate the octet rule, I need to move also the electrons in the pi bond over to the oxygen. Again, I need 2 arrows because one rule important in resonance is that we cannot break the octet rule. So octet rule is probably the most important thing that we need to remember here. Now, following the movement of electrons shown by the arrows in pink, I'm going to draw the resonance structure. And what I have here is a double bond between carbon and nitrogen. And now these electrons are assigned to the oxygen. And here we need to remember the concept of formal charges. And quickly here, any nitrogen with 4 bonds and no lone pair will have a formal positive charge. But we did that with the formula, if you guys remember from previous videos. And here, say if we have an oxygen with only 1 bond and 3 lone pair, this will have a formal negative charge. And that's another point that is important in resonance. So arrows show the movement of electrons. Keep track of the formal charges. And if you started with something that had no charges, the sum of the charges here will need to be equal to that. And here it is a plus and a minus, and here I have 0 charge. So these are my 2 resonance structure, and what I did here is noticing that I had to assign the sp2 hybridization to the nitrogen. I moved then electrons in the p orbital over to make a double bond here, but because I cannot break the octet rule, I had to draw a second arrow, opening the charge over to the oxygen. And then the sum of the charges is equal to the charge in the original molecule. Recap, arrows show the movement of electrons. Keep track of the charges, and don't ever break the octet rule. That's all for now.